Good morning. Today we are starting one more topic, that is 10th topic. Today we have to start one more topic, that is 10th topic, magnetic fields. Magnetic fields due to electric current. Due to electric currents. Magnetic fields due to electric current. ओके. सी आता या टॉपिक मध्ये काही भाग तर आपला कमी झालेला आहे. आपल्याला भाग आहे तो म्हणजेच अबाउट मॅग्नेटिक फोर्स. अबाउट मॅग्नेटिक फोर्स ऑन चार्ज्ड पार्टिकल. ऑन चार्ज्ड पार्टिकल. magnetic force on charged particle. Okay, now see, suppose this one as uniform magnetic field. Suppose this one as uniform magnetic field of magnetic induction B. आता या मॅग्नेटिक फील्ड मध्ये समजा आपण एखादा चार्ज पार्टिकल, सपोज चार्ज ऑन दिस पार्टिकल इज Q. सपोज दिस चार्ज पार्टिकल मूव्स इन मॅग्नेटिक फील्ड along this direction with velocity v and with making angle theta with direction of magnetic field. Suppose this one as a charged particle moves in a magnetic field with velocity v, making an angle theta with direction of magnetic field. See, consider a charged particle. Consider a charged particle. Consider a charged particle moves in uniform external magnetic field. Let Q, that is magnitude of charge on particle, v velocity of particle, B magnetic induction of external magnetic field, theta angle between direction of velocity of particle with magnetic field, then force, then magnetic force, then magnetic force act on charged particle, that is Fm. Fm, that is magnetic force acting on particle, that is Q into V cross B. Means magnetic force is perpendicular to the plane containing velocity as well as magnetic induction. Force is perpendicular to both velocity of particle and direction of magnetic field, which can be written as Q into Vp sin theta into n cap, where n cap is unit vector in the direction of force. In the direction of force. Okay. This is magnetic force acting on particle. That is Q phi B sin theta into n cap, where n cap unit vector in the direction of force. Okay. In presence of both electric and magnetic field, if both electric and magnetic fields are present, then force acting on particle, charged particle, that is force due to electric field plus force due to magnetic field, force due to electric field. On the last year we have see concept electric intensity, that is force per unit charge. Electric intensity at any point in electric field is the electrostatic force acting on charged particle per unit charge, and therefore electric force, that is Q into E plus magnetic force Q into phi cross P, where E electric intensity of electric field, and therefore force acting on charged particle F is equal to, in presence of both electric and magnetic field, Q into intensity of electric field plus phi cross P, like this. This is an expression for force acting on charged particle. This is force acting on charged particle in only magnetic field, and this is force acting on charged particle in presence of both electric and magnetic fields. Okay. This is about magnetic force on charged particles. Now, magnetic force. One more concept about magnetic force. Magnetic force on straight wire. On wire carrying current in uniform magnetic field, placed in uniform magnetic field. See one more term, magnetic force on wire carrying current in uniform magnetic field. आता आपण इथं कोणतं एक्सप्रेशन पाहिलं, मॅग्नेटिक फोर्स ऑन चार्ज पार्टिकल. आता पाहतोय मॅग्नेटिक फोर्स ऑन वायर कॅरिंग करंट. ओके, नाउ सी, suppose this one as uniform magnetic field, suppose this one as uniform magnetic field like this, suppose this one as uniform magnetic field of magnetic induction B, and suppose this is wire, suppose this one as a current carrying wire, suppose this one as a current carrying wire like this, suppose this one as a current carrying wire carrying current I, L that is length of wire, theta that is angle between direction of current with magnetic field, theta angle between electric current with magnetic field. Same. Consider a wire carrying current placed in uniform magnetic field. इथं जे आहे तेच आपण कन्सिडर करतोय. Consider a wire carrying current placed in uniform magnetic field. Let I current flowing through wire Q, that is magnitude of charge flowing through wire, L length of wire, B magnetic induction of uniform magnetic field, and suppose VD, that is drift velocity of charge. काय काय टर्म आलेत? I current flowing through wire, Q magnitude of charge flowing through wire, L length of wire in uniform magnetic field, B magnitude of uniform magnetic field, CD drift velocity. Then force, then charge Q is equal to, what is charge? That is current into time. Actually, what is current? That is quantity of charge flowing through conductor per unit time, and therefore quantity of charge flowing through conductor Q is equal to I into T. Q is equal to I into T, but drift velocity, that is velocity, is equal to distance covered by charge per unit time. Drift velocity is nothing but distance divided by time. म्हणजे चार्जला समजा एवढी लेंथ कव्हर करण्यासाठी, एवढं डिस्टन्स कव्हर करण्यासाठी लागणारा टाइम टी. CD, that is drift velocity, that is distance divided by time, and therefore quantity of charge, that is I into value of T, L divided by CD. Okay, and therefore magnetic force on wire, that is Fm, is equal to Q into V cross P. V means drift velocity, which is nothing but value of Q I into L divided by VD Q into VD cross P. VD by VD cancel, which is nothing but I into L cross P, which is equal to I L B sin theta. L cross B, LB sin theta into N cap, where N cap is unit vector along the direction of force. This is an expression of magnetic force acting on wire placed in uniform magnetic field. ILP sin theta. जसं इथं आहे चार्ज पार्टिकल, तसंच इथं वायर वरती पण आहे. हिअर मॅग्नेटिक फोर्स ऑन वायर. इथं आपण काय करतोय, पहिलं स्ट्रेट वायर कन्सिडर केली. आता आपण पाहतोय ऑर्बिटरी शेप्ड वायर. पहिलं इथं स्ट्रेट वायर स्ट्रेट वायर. आता इथं आपण पाहतोय ऑर्बिटरी शेप्ड वायर. आर्बिट्ररी शेप्ड वायर. Consider an arbitrary shaped wire carrying current I. Consider an arbitrary shaped wire like this. Consider an arbitrary shaped wire like this, placed in uniform external magnetic field like this. Consider an arbitrary shaped wire carrying current placed in uniform external magnetic field B. I, that is current flowing through wire. Let's suppose DL, that is length of small element of wire. DL, length of small element of wire. Now see, consider an arbitrary shaped wire carrying current placed in uniform magnetic field. Let I, current flowing through wire. DL, length of small element of wire. B, magnetic induction of uniform external magnetic field. Then magnetic force on small element of wire. Magnetic force on small element of wire. Small force DF is equal to, what is force? I into DL cross B. This is small force on small length, and therefore total force on total wire, that is F is equal to integration of DF, which is equal to integration of I into DL cross B. I constant आहे त्याला बाहेर काढ into integration of DL cross B like this. Force acting on wire F is equal to I into integration of DL cross B. Since B is non-uniform over whole wire, okay, this is about magnetic force on arbitrary shaped wire. आतापर्यंत आपण 3 पार्ट पाहिले. पहिल्या पार्ट मध्ये magnetic force on charged particle, magnetic force on straight wire carrying current, and magnetic force on arbitrary shaped wire. आता याच्या आधारे आपण आणखी एक टर्म पाहतोय, ती म्हणजेच टॉर्क ऍक्टिंग ऑन करंट कॅरिंग लूप. वन मोर टर्म, that is force acting on current carrying loop placed in uniform magnetic field. Force acting on current carrying loop placed in uniform magnetic field. Say, suppose this one as uniform external magnetic field. Suppose this one as uniform external magnetic field like this. Suppose this one as uniform external magnetic field of magnetic induction B. आता या मॅग्नेटिक फील्ड मध्ये समजा आपण ही कॉइल प्लेस करतोय, रेक्टँग्युलर कॉइल लाईक दिस. Suppose this one as a rectangular coil carrying current I. Suppose this one as a rectangular coil A, B, C, D carrying current I. Let L, that is length of coil, B, that is breadth of coil, L, that is length of coil, P, breadth of coil, and suppose N, that is number of turns. N, that is number of turns in loop. See once more. Consider a rectangular loop of wire ABCD. Consider a rectangular loop of wire ABCD carrying current placed in uniform magnetic field. बघा आपण इथं काय कन्सिडर करतोय. Consider a rectangular loop of wire carrying current placed in uniform magnetic field. Let I, current flowing through loop, L, length of loop, B, breadth of loop, B, magnetic induction of uniform magnetic field, N, number of turns, theta, angle between direction of current with magnetic field. कोणत्या प्रमाणे बघा. Let I, current flowing through loop, L, length of loop, B, breadth of loop, capital B, magnetic induction of uniform magnetic field, N, number of turns, theta, angle between current with direction of magnetic field. Now see here, as sides AB and CD diagram मध्ये पहा, sides AB and CD are neither parallel nor perpendicular to magnetic fields. As sides AB and DC are neither parallel nor perpendicular to direction of magnetic field, magnetic forces acting on them are equal in magnitude but opposite in direction and cancelled with each other. See here, as sides AB and CD are neither parallel nor perpendicular to magnetic field, and hence forces acting on them are equal in magnitude but opposite in direction and cancelled with each other. But sides AD and BC, बघा या डायग्राम मध्ये sides AD and BC are perpendicular to direction of magnetic field. Sides AD and BC are perpendicular to magnetic fields. Force acts on each side. But sides AD and BC are perpendicular to magnetic field, and therefore force acting on each side, that is force F, is equal to I into L cross B. As sides are perpendicular, force becomes I L B sin theta. But loop has n terms, and therefore resultant force theta n, that is force acts on each side, that is n I L B into sin theta. Thus two equal in magnitude and opposite forces. Thus two equal in magnitude and opposite forces. यावरती जेवढा फोर्स निर्माण होतो तेवढाच फोर्स इथे निर्माण होतो. But as direction of currents are opposite, direction of force are also opposite. Forces equal आहेत, but directions opposite आहेत, which produces torque. Thus two equal in magnitudes, but opposite directions. Thus forces acting on two sides are equal in magnitude but opposite direction, and hence torque acting on them. What is torque? Magnitude of one force into perpendicular distance between them, that is B, where B, that is breadth of coil, means distance between these two forces. Two equal in magnitude but opposite forces acts on them, and hence torque acting on them. What is torque? Magnitude of one force into perpendicular distance. फोर्स किती आहे? एन आई एल बी इंटू साइन थीटा इंटू बी, but length into breadth, that is area of coil, and therefore torque, that is N I A B, N I A B sin theta. This is an expression of torque acting on current carrying loop placed in uniform magnetic field, where L into B, that is area of coil, length into breadth, L length of coil, B breadth of coil, length into breadth is nothing but area of coil. this is about torque acting on current carrying loop in uniform magnetic field. हा झाला आपला पहिला पार्ट. कोणता? अबाउट मॅग्नेटिक फोर्स. काय काय पाहिलं आपण? मॅग्नेटिक फोर्स ऑन चार्ज पार्टिकल, देन मॅग्नेटिक फोर्स ऑन स्ट्रेट current carrying conductor in uniform magnetic field, then magnetic force on arbitrary shaped current carrying wire, and torque acting on. खरं तर इथे एक्सप्रेशन आहे टोर्क, TORQUE, torque acting on current carrying loop placed in uniform magnetic field. What is torque? NIAB sin theta, where theta angle between direction of current with magnetic field. ओके, तर हा झाला आपला पहिला पार्ट. सेकंड पार्ट अबाउट बाइट-सॅवर्ट लॉ अँड थर्ड पार्ट अबाउट एम्पियर्स लॉ. 3 पार्ट त्यामध्ये. ओके.